Good morning, students. Welcome to the online classes. So, in the previous class, we have discussed about the conduction, which is a process of transfer of heat, and the second process of transfer of heat is convection. Okay. So today we will discuss about convection. So, convection is a process of heat transfer by the actual movement of medium particles. So, in case of conduction, there is no movement of the particles, but here in case of convection there should be a actual movement of the medium particles. So this is only shown by the liquid and gases. Okay, so liquid and gases are poor conductors of heat. They are heated mainly by convection only. So in solids the particles have do not leave their positions because they are tightly packed. So the solids are not heated by convection. Okay, as the particles of the solids are very tightly packed, that means the intermolecular space between the solids is very less, so they are tightly packed and they cannot move. That's why the convection is only shown in liquids and gases. In convection, the transfer of heat is always vertically upward. That means first the lower part will be heated, then gradually the heat will be flow upward. Okay, for example, you can take, if you want to boil a if you want to boil a pot of water, then the bottom part of the water which is in the bottom of the pot will be first heat up, then it will gradually go upward, then whole water in the bottom pot will be heated. So the reason being that the medium particles near to the source of heat, after absorbing heat, start moving faster, so they become farther. Okay, the medium expands. As a result, the density of the medium near the source of heat becomes less and it becomes lighter. So the less dense medium raise up and the denser medium from the above moves down to take its place. That means while heating the bottom part of the liquid or gas, what should it will expand by gaining the heat energy. They will also they by gaining the energy, their density will also less. So the less dense will be go upward because the less dense will be move upward, raise up. That's why the denser medium of the above will move down and they will take the bottom place now. After that the bottom those part will be heated up. So thus a current is set up in the medium which is called as convection current. So the upper medium or the upper part is denser and it is coming down, and the lower part after heating will be less denser, then it will be move upward. So there will be a change, there will be a current is produced. So this current is known as what? Convection current. Okay, then there are different type of convection shown by the liquids and gases. So one by one we will see. So the process of convection in liquid can be easily demonstrated by the following activity. So let us see the activity 14. Okay, so you can see the figure here. You can see the figure. So in activity 14, what we have to do? In activity 14, then first take a bottle, fill it with about 3/4 of water, gently drop few crystals of potassium permanganate into the bottle to make the water colored. Okay, when you put some potassium permanganate, the water color should be light pink or dark pink. Okay, so fix the bottle on the vertical stand and heat it over flame of burner as shown in this figure. Okay, you can see the figure here. Now you heat, this is the potassium permanganate crystal, this is the crystal, we have not mixed up yet. So this is a crystal. When you heat it up, then what will happen? You will notice that a fine stream of color water starts from center of the bottom of the bottle. It rises upward, reaches the top of water, and circle downward along the side of the bottle. So this stream present the convection current. Okay, then what will happen? We will see that the potassium permanganate, the colored stream will be move upward. The color part will be move upward, and uncolored part will be moved downward. So you can see a stream like structure, and that stream is called as convection current. Okay, so this is the convection in case of liquid. Then for convection in case of gas, we have to see the activity 15. Okay, you can see figure here. Okay, this figure you see. Okay, so this is the figure. Okay, in this activity, what you have to do? Take a rectangular cardboard box, cut the longer side, if it side of it, and then cover it with a transparent polythene paper. Okay, then keep this side of the box upward facing towards you. Then cut a window on the other side of the box as shown in the figure. So you can see the figure here. So this side is the transparent polythene, and this is the window which is on the other side. Okay, then what you have to do? Then so that window is for insert the hand. Okay, cut two holes on the top of the box, then roll two pieces of paper and insert them in the holes. Then serve as upper chimney. So these two in these two holes you just make a roll of papers, then you get insert in those two holes, then they will work as a chimney. Okay, then what you will do? Make them as A and B as given here. This one is the A and this one is B. Okay, then now take a small candle, light the candle and insert inside the box just below the chimney A. So what you do is shown in the figure here, that just a candle is placed just near to the chimney A. Then chimney A through the window. So by putting a hand through the window, you have to put a candle under the chimney A. Then what will happen? Then you notice that a smoke of dhoop. You will notice that the smoke of, so then what you do? Then hold a lighted dhoop or agarbatti near the mouth of chimney B as shown in the figure. So first you will keep the candle here. Then what you will do? Then you just keep a lighted dhoop or agarbatti on the over the chimney B. Then you will notice that the smoke of dhoop kept near the mouth of chimney B enters through the chimney B inside the box and comes out through the chimney A. Okay, then what will happen? This dhoop or the smoke from the agarbatti will move inside through the chimney B, and it will come outside of the chimney A. So you can also see the convection current moves from the chimney B to the chimney A. So through the polythene paper, it could be a transparent. That's why you can see also. So how the smoke of agarbatti is going inside in chimney B and coming out of that box from chimney A. What is the reason? The reason is that the candle heated. What is the reason? The reason is that the candle heats the air surrounding it as well as the air inside in the chimney A also. So this air becomes less dense and lighter, and it rises upward. So whatever may be the thing, if it will less dense and lighter, then it will move or upward, or it will raise upwards. Okay, so its place is taken by the cold air rushing down through the chimney B. Okay, by carries the smoke of the dhoop as we kept at the mouth of chimney B. Okay, now this incoming air gets heated up and rises up, thus it forms a convection current of smoke through the chimney A. So this is the reason that's why the dhoop flame or the dhoop smoke is coming inside the B and coming outside the A. Okay, then we have some application of convection in daily life. So first one is the ventilators and windows are provided in room for proper ventilation. Okay, then second one is what? Then second one is chimneys are provided over a furnace of factories. Okay, what is the reason? This is because the hot gases coming out of the furnace are less dense than the air. They rise up through the chimney and smoke, fumes, etc. around the furnace rush in so as to take their place and they are sucked out. Okay, thus the chimney helps to remove undesired fumes, smoke, etc. from the premise. Okay, then the land and sea bridges are formed at places near sea. Okay, during summer in places near the sea, it is noticed that a bridge blows from land towards the sea during the night and it is called as land bridge, and from sea towards the land which is called as sea bridge. Okay, so the land and the sea bridge are actually local convection. Okay, so how they both are happening we'll see here. See the figure. So see the figure, this one is the land bridge. Okay, so in land bridge what will happen? So at night the land cools much faster than the sea, therefore the sea water is warmer than the land. Okay, then the air near the sea being warm is less dense or lighter also, so it raises upward. Okay, so it will raises upward. We have already I've already told that if the if it will be less dense and then it will be lighter and will move upward, it raises upward, and cold current is of air blows from a cold land. So then as it is move upward, then the cold air should be feel that part which is left here. Okay, so that part that means a cold air should be flow from land to sea. Okay, so the cold land from the cold land to the warm sea to take its place, so this is called land bridge. Okay, so that means the from the land. Okay, so the bridge blows from the land towards the sea during the night is called as a land bridge. Okay, this is the land bridge. How why land bridge is happening you have seen. The next one, the sea bridge. Okay, so in daytime, in summer day, in daytime what will happen? During day the land becomes more warmer than the sea, so the air above the land being warmer becomes less dense or lighter than its range of, and the cold air from the sea blows towards the land to take its place as shown in the figure. You can see the figure here. Okay, so this is called as a sea bridge. Okay, so these all are due to local convection only. Okay, then number 4. Okay, uh, ocean currents flows on the surface and below the surface, like that surface of the ocean. Okay, this is due to convection only. Okay, ocean currents are caused due to convection currents in the ocean. The ocean water near the equator is heated by the sun more than the water near the poles. Okay, so then what will happen? Then the water near the equator is warmer than the that of the pole. Therefore, a convection current of warm water flows on the surface of the ocean from the equator to the poles. while below the surface of the ocean, currents of cold water flows from pole to the equator. Then that means on the surface of the ocean there will be a flow of water from equator to poles, but inside the ocean or below the surface of the ocean, then a cold water will flow towards the from poles towards the equator. Okay, so these currents are called ocean currents, and they are controlled by they control the temperature of the sea also. Okay, so ocean currents also controls the temperature of the sea. Okay, then a refrigerator also shows so convection part. So how it is showing, we'll see here. Okay, a refrigerator is provided with its cooling or freezing just near its top. Okay, so what is the reason that the ice chamber which is present in the top? So the reason is that the air near the top in contact with the freezing chest, that means the ice box, we can say, uh, get cooled, it become denser and heavier. Then if it will be become denser and heavier, then it will be uh, descending down. Okay, then it descends down, then the hot air from the lower part will be raised up, thus thus a convection current is also formed here. Okay, so the cold air coming down from the cooling chest cools the entire space, the things present in the refrigerator below the cooling chest, like this. Okay, so this is why the ice chamber which is present in the top part of the refrigerator. The next one is 6, which is so the sixth example we can take. So for heat insulation of a room in a house, whether stripping or curtains are used. The weather strippings close the small opening of the window so that no heat goes out by the convection. Okay, so the curtains pulled down over the window from a layer of steel air between the window and curtain to act as an insulator. This we have discussed in the previous class also, why the curtains are used in the windows. Okay, then the next one is 7 number. The room heater and blower are kept on the near the floor of the room so that the hot air may rise up and warm the entire room. That's why always the ACs are put above and room heaters are put down. Okay, so if room heaters are put down, then the down part will the bottom part of the room will be first heated up, then those will be go upward. For air conditioner, for AC, what will happen? First the upper part of the room will be cool down, then it will be fall down. Okay, then it will be, we can say, descend down. Okay, that's why we are using ACs at top part of our room and heaters at the lower part of the room. Okay, firemen usually close while entering a building. Okay, so crawl, why they are crawling? So where the fire has broken out because the hot air and smoke raise upward. So that means the hot air and smoke can be is present on the upper part of the room, and the down part should not that much of heat, contain heat, hot air or smoke also. Okay, so that's why they are crawling on the while entering a building. Okay, for the firemen. Then next we have radiation. Okay, so the next part is what? Next part is radiation. So what is radiation? We will see. Okay, so radiation. So radiation is the process of also heat transfer, which heat directly passes from one body at a higher temperature to another body at lower temperature without affecting the medium. Okay, so For fast case conduction, we have to be, the body has to be in contact. For convection, they are taking part the molecules of the medium, and here without contact, that is the heat should directly pass from one body to another body. Okay, from high temperature to lower temperature without affecting the medium. So here the medium will be not affected. The medium is required for transfer of heat by the process of radiation. That means there is no medium is required for the process of radiation. In vacuum, heat transfer takes place only by the process of radiation. So you can see the better example is we can sit in the sun, we feel warm. Okay, we cannot get heat from the sun by the process of conduction or convection, but most of the space between the sun to the earth is a vacuum. So both those modes are required medium for heat transfer, but we are getting heat from the sun. So hence we can must getting the heat from the sun by the process of radiation only. Okay, then example 2, when we sit near a fire, we feel warm also. So this is also another example of radiation. Okay, then radiation are also called as radiations, or heat radiations are also called as radiations or thermal radiation. So they travel in a straight line with a speed of 3 to 10 to the power 8 meter per second in vacuum or air. Okay, so this is the speed of light also. Okay, so they are similar in the properties of light, with the only difference is that heat radiation does not give the sensation of sight as light does. Okay, but heat radiation gives the sensation of hotness. Okay, so this is the only basic difference between the light and heat. Okay, so when radiation falls on a body, the body absorbs some of them and reflects the rest. Okay, the body becomes warmer because it absorbs the radiations. Different substances absorbs different amount of radiations falling on them. Okay, that means depending upon the nature of the body, it will absorb the heat radiation. Okay, a body which absorbs more radiation or reflect less become more warmer, while a body which absorbs less radiation but reflects more will be less warmer. Okay, experimentally we can observe that the black and dull surface absorb more radiation, reflects less radiation. Okay, uh, then we have the white and shiny surface reflects more radiation and absorbs less radiation. So solar cooker are used, this is the do you know part, solar cookers are used the heat energy of the sun to cook the food only, that is due to radiation only. Okay, the inner part of the inner surface of the inner surface of that solar cooker is painted black, so that it absorbs maximum amount of solar energy which is falling on them. Okay, then the its following activity shows black surface are good absorber than heat rather than the white surfaces. Okay, then here what you have to do, take two identical cold drinks, then what you will do here, take two identical cold drinks can be filled with equal amount of water. Paint one can black and the other one white from the outside. Place a thermometer in each can with the bulb of the thermometer properly dropped in the water. Now place both the cans at equal distance from the room heater. Then switch the heater on and let it remaining for the 15 minutes. Then you will observe that the temperature reading of the thermometer placed inside black can is higher than the reading in the thermometer placed inside the white can. So this proves that black color absorbs more heat and it becomes more hot. Okay, so some application of black and white surfaces in daily life we can see. So we prefer to wear white clothes in summer So the reason is that it is less warmer. Okay, then it will cool, it will keep our body cool. Then the next one is we prefer to wear black or dark color in the winters because they will hold the, they will absorb the sun's heat and keep our body warmer. The bottom part of the cooking utensils are painted black. The reason is that it absorbs more heat, and the contents of the utensil or the pan get cooked rapidly by the more heat. Okay, then room heaters are provided with shiny reflectors. So because of that, its shine surface are absorb very little amount of heat and reflects most of it, so that almost the entire heat produced by the filament of heater is reflected. So this is the some of the examples we have used as black and white in the daily life. So do you know no part is there? It is cool in the shade below a tree, but not little away from it. So the reason is that heat radiation travels in a straight line. So therefore, the heat radiations from the sun cannot reach the shadow below the tree, as tree are absorbed by the leaves. Apart from it, the air trapped between the leaves is a bad conductor of heat also. So it does not allow heat to pass from the above tree and etc. That's why we feel cool in the shadow below a tree. Okay, then if a red hot balloon is suspended from a roof of a room by the thin metallic wire, it will lose heat by conduction and convection through the air moves around the ball. Secondly, by conduction through the metal wire, and thirdly, by radiation from the ball and wire to the surrounding. Okay, so it will show three type of radiations. To reduce hot loss, to sorry, to reduce heat loss by radiation from the surface, it is made shiny. So if you want to uh, heat radiation, then you have to paint it shiny. Okay, then next we have the difference between conduction, convection and radiation. We have already discussed about it. I hope you will read and you will understood this one. Okay, then we have the thermoflask. Okay, so the thermoflask, so you can see figure here. So what is the construction, we will see here what is the thermoflask and how it is constructed. So the thermoflask is a special kind of flask or bottle. It is used to keep a hot liquid or cold liquid cold. So it will keep hot liquid hot and cold liquid cold for a long time. A thermoflask is shown in the figure. This one you can see the figure here, thermoflask. This is the thermoflask. Okay, so how it is made up of, we will see now. It consists of a double-walled glass bottle. You can see the double-walled glass bottle here. This is the double-walled glass bottle. Okay, then there is a vacuum inside, in between the walls is also there. Okay, so vacuum is also present inside in between the walls. This is the vacuum present in between the walls. Okay, so see, the red part is the vacuum and this is the double walled, you can say this is the inner one and this is the outer. Okay, so the inner wall, both the walls are made up of shiny uh, on the vacuum side, and okay, so the mouth of the bottle is fitted with a cork or plastic stopper. So this one is the plastic stopper or cork stopper, this one. Okay, the bottle is enclosed in a plastic case with the help of cork pieces or spring edges which soak absorber, which is a good absorber also. This case is provided with a cap cover the stopper. So this is a cap also. Okay, and then we have So the vacuum in between the two walls, this is the vacuum in between the two walls. The vacuum in between the two walls of the bottle prevent by transfer of heat by the conduction and convection. Okay, so as there is no medium where vacuum is there, that means there will be no possibility of conduction and convection. And the shiny surface of the outer side of the outside of the inner wall uh, and the inner side of the outer wall reduces the transfer of heat by radiation. So if there is a shiny is there, then there will be no radiation, less radiation we can say. Okay, so the cork stopper prevents the transfer of heat by convection. Thus, the transfer of heat either from the outside inside to outside or from outside inside is very little. So that's why it can hold the cold and hot temperature hot for a long time. Okay, so this is the reason. So some examples are given. I hope you have to see these examples. We have already discussed about these examples in the previous some classes also. Okay, how to convert from Celsius to Fahrenheit, Fahrenheit to Celsius, Kelvin to Celsius, like that. Okay, so this concludes your chapter 5, heat energy. And if you have any doubts regarding this heat energy, you can ask. So thank you. Have a nice day.